Hello everyone, today we'll talk about the problem path with maximum gold. We're given an m by n grid, and in each cell we have some gold, which is a positive integer, or 0 if it's empty. We have to gather as much gold as possible, subject to the following restrictions. We can start at any position, however we can never visit the same cell twice. We cannot visit any cell that has no gold, so we have to essentially walk through a connected path of cells that have some gold. We can walk up, down, left, right, and of course we collect the gold in every cell we visit. Now in general, in problems like this, when there is a grid, we want to optimize something such as this maximum gold, or perhaps in problems like word search, but anyways where we can just go up, down, left, right arbitrarily. The solution is typically just implementing what is being asked of us as a simple backtracking algorithm. Right? So essentially this is just an implementation problem. We have to do a simple backtracking, and in general we can verify it if we look at the constraints that m and n are small. Or in this case we are also guaranteed that the cells with gold, the number of cells with gold is small. Because an exponential solution, and backtracking solutions are exponential, will very quickly become too slow as m and n increase. Anyway, we just have to implement it, so we remember the height, the width, we remember the 4 directions that we can go in, and we'll have a helper function that will give us how much gold we can get starting at a given position. So then our result is just the maximum over all the rows and columns of what we can get starting at that position. And now we can, at every step in that helper function, we can just take all the gold that's within it. By taking the gold and setting the appropriate grid cell to 0, we make sure that we never visit it again. And then we just go in all the 4 directions, and if we're within the grid and there is some gold, so if this is 0 then we cannot go there, if it's not 0 we can go there. So we just recursively run our helper function at that new cell and add it to our result, and we take the maximum over all the moves that we can make. And of course, since this is backtracking, then we have to mark all the visited cells, and then mark them, mark them as not visited, right? So essentially to clean up after ourselves. So we just do it like this. Here we set it to 0, and here we set it back to the original value, and that will just, in that case, let us visit all the possible paths, and of course then the answer is the best of what we visited.